In this video, we will discuss about scalar product or also known as dot product. There are three main learning outcomes. First, we will learn on how to find the scalar product. Next one, use the properties of scalar product. And last part, the application for scalar product, we will learn on how to find the angle between two vectors. So, by definition, the scalar or dot product between vector A and vector B is defined as A1 times B1 plus with A2 times B2 plus with A3 times B3, provided that A1, A2, A3, B1, B2, B3 are the element of ij, k in vector A and vector B. We have five main properties for scalar product. The first one, if we have vector A dot with vector A, we will get magnitude of A squared. Second one, vector A dot with vector B is the same as vector B dot with A. The third properties is about A dot B plus C is basically the expansion of it, A dot B plus A dot C. And then for number 4, we have C as a constant. So C times A dot B is basically the same as C times with A dot B and basically the same as A dot C times B. And last one, if we have 0 dot with vector B, we will get 0 as our final answer. Next one, this is the formula on how to find angle between two vectors. So our formula is fixed. Our theta or angle is basically arc cos of vector A dot vector B divided by magnitude of A, magnitude of B. Another rule that we will use for dot product is whenever we want to prove a perpendicular vector or two vectors that are orthogonal to each other. So if two vectors are orthogonal or perpendicular to each other, A dot B will be 0. So we have to find A dot B for the following. Provided that A and B are vectors here, so you can recognize it because we use bold for letter A and B. So this is basically a vector. So for part A, we have magnitude of A is 12, magnitude of B is 15, and the angle between A and B is pi over 6. So we have a hint here about angle. So in order to find the dot product between these two, we have to use angle formula. So as before, theta is basically arc cos of A dot B divided by magnitude of A, in this case is 12, and magnitude of B, in this case is 15. So what is theta? Theta in this case is pi over 6. If I transfer our arc cos to left side, we're going to get cos. Means in this case, cos pi over 6 times with 12 times with 15 will be equal to A dot B. Next part, you just have to compute it using your calculator. Make sure using radian mode as pi over 6 is in radian. So our final answer for this part, A dot B is basically 90 sub 3. Make sure whenever you perform the dot product between two vectors, you will get scalar as your final answer. Let's try another one. So part B, given that vector A is 5, 0, negative 2 and B is 3, negative 1, 10, find A dot B. So for this question, we don't have any angle in our statement, so we don't need to use any angle formula. Straight away to perform A dot B, I transfer vector A into column vector form. So this would be 5, 0, negative 2 dot with 3, negative 1, 10. After that, just multiply with the same element. So for element I, we have 5 and 3. So we have 5 times 3. In this case, it will be 15. Plus with 0 times with negative 1 for element J. 0 and negative 1. So we get 0 here. Plus with a multiplication between element K. So we have negative 2 times with 10. So here we get negative 20. In this case, our final answer will be negative 5. We try once again with another one, part C. So we have vector A dot with B, where our vector A is S, 2S, and 3S, dot with vector B, 1, -1, and 5. Remember, just perform multiplication with the same element. So we will have S minus 2S plus with 15S. In this case, our final answer will be 14S. Next question. Given vector P and Q, first part A, we have to find P dot Q. So as before, I just transform this into column vector form. For vector P, we would have 2, 3, 5. Dot with vector Q, we have -5, -6, and 7. So the dot product between these two, we will get -10 minus 18 plus 35. Simplify this up, we will get 7. And that is basically dot product between P and Q. Part B, we have to find magnitude of P and magnitude of Q. So remember, whenever we have a modular sign in our vector, that's represent magnitude. So for magnitude of P, it's basically set of summation of squared of every element. So now we would have 2 squared plus 3 squared plus 5 squared. In this case, we would get set of 38. Next one, we have to find magnitude for Q. So set of -5 squared, so 25, plus with -6 squared, so we get 36, and last one plus with 7 squared, so we get 49 here. So sum this up, we get set of 110. Normally for magnitude part, leave your answer as exact value. So leave it in a set form. Don't take decimal place. And then last one for part C, we have to find the angle between P and Q. So as our formula just now, our theta is basically arc cos of P dot Q divided by magnitude of P and magnitude of Q. All this info, we already find this before, so just directly substitute into the formula. We would now have arc cos of 7 divided by set of 38 times with set of 110. Next, just directly compute into your calculator. Our final answer for this one would be 83.78. And that's how we find angle by using dot product formula. Moving on. Next one. We have to show that I dot j is basically the same as j dot k equal to k dot I, and all these are 0. So before we start with the process, first we have to define first what is actually vector I, j, and k in 3 dimensions. So for vector I, it means that we only have coefficient for I. That's why we get 1, 0, 0. Next one, for vector j, we have only coefficient for j element, so our vector will be 0, 1, 0. And for vector k, this will be 0, 0, 1. Now, just straight away perform dot product for what the question asks for. First one, we have I dot j. So basically 1, 0, 0 dot with 0, 1, 0. Here we will get 0 plus with 0 plus with 0. So final answer will be 0. Now for the second statement, we have j dot k. So we would have 0, 1, 0 dot with 0, 0, 1. So our answer here is still 0. And last one for k dot I. So we have 0, 0, 1 dot with 1, 0, 0. Our final answer will be 0. And this is basically how you show for this question. Next one. So the same pattern, but now we have to show that I dot I is equal to j dot j equal to k dot k, and this is basically 1. So for I dot I, this is basically the dot product with the same element. So we have 1, 0, 0 dot with 1, 0, 0. That's how we get 1 as our answer. Moving on, second one, we have j dot with j. So 0, 1, 0 dot with 0, 1, 0. So our answer here also would be 1. And last one, k dot with k. So we will have 0, 0, 1 dot with 0, 0, 1. And our answer is still 1. Next part. So show that A and B are orthogonal. So in other words, orthogonal is basically perpendicular to each other. What does it mean by perpendicular? The angle between those two would be 90 degree. So in order to prove this part, just make sure the dot product between these two vectors must be 0. So now we perform vector A dot with vector B. We have 2, 5, negative 9 dot with negative 5, 11, 5. So now we would have negative 10 plus with 55 minus 45. And here our final answer would be 0. So we can conclude that A is perpendicular to B. Okay, next question is about simplify our dot product. For this type of question, they didn't define the element of I, J and K for each vector, so we have to use the properties. So for part A, we have to simplify vector A minus B dot with vector A plus B. Since we have dot here, so first part, we have to expand our bracket. Same as a normal process, but then make sure you cannot leave our dot symbol. So first one we would have A dot with A. Next one plus with A dot with B. Moving on, next one we would have minus with B dot A. And last one we would have B dot B. Okay, after that, simplify using properties. For the first part, A dot A, since this is dot product with the same vector, we can simplify as magnitude of A squared. A dot B and B dot A is basically the same thing, so this can be cancelled out. And then last one, for B dot B, we can rewrite this as magnitude B squared. Next question. We have A plus B dot C minus A plus C dot B. So for the first step, same as before, expand it normally, but don't leave our dot sign. So we would have A dot C plus B dot C minus with A dot B minus with C dot B. Next, we can cancel out B dot C minus C dot B. So what we have now would be A dot C minus A dot B. Or we can factorize A out. So we would have A dot with C minus B. So for this whole process, you just expand everything normally, but don't leave our dot sign. Next question. Given the vector A and B in this question, find T if A is perpendicular to B. So now for sure we know that A is orthogonal to B. Our statement from this would be A dot B must be 0. So from here we have to find T. So vector A I transform into column vector. We get 3 T negative 2 dot with vector B, we would have 1 minus t, negative 3, 4 equal to 0. So expand this up, we get 3 minus 3t minus 3t minus 8 equal to 0. And simplify this up, finally our t would be negative 5 over 6. Last question for dot product. So if the angle between vector A and vector B is arc cos of 1 over sec 84, find lambda. Okay, so now we have a statement here that our angle is this. So directly transform this into formula. We know that in order to find angle, our formula is basically arc cos of vector A dot with vector B divided by its magnitude. So now we can compare this with arc cos of 1 over sec 84. So let's find one by one first. For the first part, A dot B. So if I transform A into column vector, we have 1, lambda and 2. Dot with vector B, we have 2, 3 and 1. Simplify this up, we would get 4 plus 3 lambda. And then for magnitude part, magnitude of A would be sine of 1 plus lambda squared plus 4. And then for magnitude of B, we would get 4 plus 1 plus 9. So this would be equal to sec 14. Okay, so from our statement just now, we can compare it. So I rewrite it back now. Our arc cos of A dot B is 4 plus 3 lambda divided by its magnitude. So we have 5 plus lambda squared times with sec 14 is basically the same as arc cos of 1 over sec 84. Alright, so from this statement, just compare with the same level. So I just compare our numerator part here to obtain lambda. Once we compare this up, 4 plus 3 lambda is basically 1. So finally, our lambda would be negative 1. So that's all for dot product